Radio observations show intense energy emissions exactly where the black hole is expected to be, confirming that it is actively consuming matter. Yet the most unsettling aspect of the infinity galaxy collision isn't what we can observe right now. It's what this discovery hints at regarding the violent processes that shaped the early universe. If direct collapse black hole formation was common during the cosmos's youth, it means the universe went through an era of incredible chaos and violence that we're only beginning to understand. That violence also left behind objects even stranger than wandering black holes. Hundreds of orphaned worlds drift through space in pairs, broadcasting radio signals that shouldn't exist. James Webb has identified over 500 free-floating planets in the Orion Nebula that don't orbit any star, each roughly the size of Jupiter. These cosmic wanderers were ejected from their original solar systems, and now drift through the cold emptiness of interstellar space. Many travel in pairs, orbiting one another at distances ranging from 25 to 400 times the distance between Earth and the Sun. Scientists call these paired wanderers Jupiter mass binary objects, or JAMBOs. They challenge every theory of planets typically forming gas and dust disks around young stars, slowly accumulating material until they reach their final size. The gravitational choreography required to create binary planets should be extremely rare, yet Webb has found dozens of these cosmic couples. The mystery deepened when astronomers aimed radio telescopes at these paired planets and discovered something unprecedented. Several JAMBOs emit radio signals with patterns never before seen from planets. These aren't the typical emissions from magnetic fields interacting with charged particles. They are gigahertz frequency radio bursts thousands of times higher than FM radio signals. On Earth, signals at these frequencies come from technological sources or extremely energetic astronomical phenomena like pulsars and quasars. The fact that rogue planets emit them suggests these worlds experience physical processes not found anywhere else in our solar system. The radio emissions seem linked to the planet's binary nature when two massive objects orbit each other. Complex gravitational interactions generate powerful magnetic fields and electrical currents. Think of it as cosmic friction on a scale we've never seen. These JAMBOs are essentially giant electrical generators powered by their orbital dance. Yet the signals remain deeply puzzling, with each pair producing unique radio signatures, some steady, some sporadic, none following an obvious pattern. The implications are unsettling. If these orphaned worlds can generate such powerful radio signals, what else might they be capable of? Their magnetic fields could be far stronger than anything in our solar system, creating space whether that could affect nearby star systems. Even more disturbing is what the existence of so many JAMBOs implies about planetary system formation. If hundreds of these paired worlds exist in just one nebula, there could be millions or billions scattered throughout our galaxy. Each represents a failed solar system, a cosmic tragedy where gravitational interactions went wrong, ejecting planets into eternal darkness. These rogue worlds are cosmic orphans, forever separated from the warmth and energy of stars. Their only heat comes from radioactive decay in their cores and tidal forces generated by their orbital dance with their companion. As strange as these wandering planets are, Webb discovered worlds that challenge our understanding of planetary formation in even more fundamental ways. A young star system defies basic rules of planet formation, creating worlds made of unexpected materials. In the star-forming region known as NGC 6357, Webb discovered a planet-forming disk that contains almost no water but is rich in carbon dioxide, exactly where Earth-like planets should be forming. This finding shatters one of the most fundamental assumptions about how rocky planets develop around young stars. Every model of planetary formation assumes regions around young stars where rocky planets form should be dominated by water, ice, and silicate minerals. Water is one of the universe's most abundant molecules, considered essential for creating potentially habitable worlds. Yet the disk around the star's U upends these assumptions. Using Webb's near-infrared spectrograph, astronomers expected to see the familiar signature of water vapor mixed with other common compounds. Instead, they found a disk where carbon dioxide dominates typically form. Water is so scarce that it's barely detectable, creating an environment unlike anything previously modeled. A planet forming in the Zu-10 system would develop under completely different chemical conditions, potentially creating worlds with no analog in our solar system. Two theories attempt to explain this bizarre chemistry, both with unsettling implications. The first suggests intense ultraviolet radiation from the young star or nearby massive stars sterilized the disk, breaking apart water molecules and driving hydrogen away while leaving oxygen to bond with carbon. The second is even more disturbing. Carbon dioxide dominance could result from unusual conditions in the dust grains forming the disk. Instead of being coated with water ice like dust grains in normal systems, these particles may be covered with carbon dioxide due to environmental conditions around this young star. Either scenario shows that planetary formation can follow pathways astronomers never imagined. If UV radiation can strip water from planet-forming disks, many potentially habitable worlds might never acquire the chemical building blocks needed for life. The galaxy could be filled with dry carbon dioxide-rich planets formed under conditions hostile to life as we know it. Webb's discoveries didn't stop with chemistry. The telescope next found a planet with an atmosphere so extreme it challenges every definition of planetary science. 55 Cancri E orbits its star so closely, it completes a year in just 18 Earth hours. Tidally locked, it always shows the same face to its star, creating a dayside hot enough to melt copper and a nightside plunged into eternal darkness. Surface temperatures exceed 4,000 degrees F, enough to vaporize most known materials. By every rule of planetary physics, this world should have lost its atmosphere billions of years ago. Yet Webb found that it not only has an atmosphere but one composed of materials that shouldn't exist as gases at such temperatures, rich in carbon monoxide and carbon dioxide. The planet's atmosphere redistributes heat from the dayside to the nightside, creating supersonic winds that carry vaporized rock and metal, which condense on the nightside and rain down as molten minerals. It functions as a massive distillation apparatus under conditions that push the boundaries of physics. The atmosphere seems to be a secondary one, continuously replenished by geological processes from the planet's boiling interior. Rock vaporizes, is blown around the planet, condenses, and rains back down, an impossible, hellish cycle that keeps the atmosphere alive. Webb's next target revealed an interstellar visitor that challenges our understanding of time. Comet 3I Atlas, an ancient traveler from another star system, is older than the Earth, the Sun, and everything we call home, approximately 7 billion years old. It comes from the Milky Way's thick disk, a region filled with ancient stars formed when the universe was much younger. This comet predates all planets in our solar system, carrying chemical signatures from an epoch long before our Sun existed. Traveling at over 130,000 miles per hour, it obeys galactic gravitational rules rather than those of our Sun. 3I Atlas is only the third confirmed interstellar object ever discovered, yet statistical models suggest dozens or hundreds may pass through our neighborhood at any given time. Each is a fragment of a destroyed world, a time capsule from an ancient universe, carrying information no other object can provide. These cosmic discoveries remind us once again how strange, violent, and unexpected the universe truly is. Our observations reveal not only stars and planets but also the complexity and history of the cosmos itself. Every new finding challenges the truths we thought we knew and redraws the boundaries of the universe. Perhaps we are small spectators trying to understand this cosmic story, yet each discovery demonstrates the power of human curiosity and the drive of science to push boundaries. The universe is full of surprises beyond our imagination, and we are only seeing the beginning.